Yes, dear student, there is a very good question for class 11 students in rotational motion. Find the components of environmental L of particle along x, y, z axis whose position vector r has x, y, z coordinates and linear momentum p has components px, py, pz along x, y, z axis. If particle rotates in xy plane, then prove that vector L has only z component. It has only z component. For learners, actually this chapter appears to be a trouble, but please keep on doing again and again and keep on thinking again and again, and you will be master of this chapter. I know what difficulty I have faced. Actually, I had to read many times from NCERT book, from different books, and then kept on thinking that I will be able to understand. And I am now, in one sense, master of this chapter. I can't say master, but well versed I can say. So, you are given position vector. Here, answer solution like this. Here, our vector r will be x I cap plus y j cap plus z k cap. If x, y, z are the coordinates of position vector or coordinates of position of particle, then which position vector r is equal to x I cap plus j cap x j cap plus y k cap z k cap. I, j, k cap, you know, they are in vector along x, y, z axis. And vector p will be px I cap plus py j cap plus pz k cap. My dear friend, please, if you don't understand vector product, please see my video of vectors. There is a playlist for scalar vector in my this account of YouTube. That please learn about vector product, which is very important. In class 11, 12, there are many topics which cannot be done without the knowledge of vector product. We know vector L is equal to R cross P, not P cross R. It is R cross P, cross product. Don't speak into, speak cross. Vector L is equal to R cross P. I told you while driving, this expression for this. So it is x I cap plus y j cap plus z k cap. Cross, not into. Px I cap plus py j cap plus pz k cap. Now to find vector L, actually we go this way also. I, j, k. And then x, y, z, px, py and pz. This is equal to ypz minus zpy into I cap plus j. Go this way. पहले हमने ऐसे चले थे first step. Now first step is this. It is pxz, यानी कि z px भी सकते हैं, और माइनस xpz j cap प्लस xpy minus ypx k cap. If you repeat many times, you don't require to think. You can write the answer very frequently. and therefore here vector L, therefore vector L equal to क्या भाई ypz minus zpy I cap plus भाई zpx minus xpz j cap plus xpy minus ypz ypx sorry px k cap, and hence component of vector L along x y z axis, and hence components of vector L along x, y and z axes has magnitudes क्या भाई Lx equal to ypz, we have proved it. But if this comes this way, Ly zpx minus xpz, in fact now I don't require to see to or Lz xpy minus ypx. You know P equal to mv also. Linear momentum P equal to mv. I solved a question based on this. Now here you are asked here if particle rotates in xy plane or particle moves in xy plane, then show that vector L has only component along z direction. If particle moves, not only rotate, moves or rotate, both दोनों आ सकते हैं, rotates in xy plane, then z equal to 0 and pz यानी कि mvz is also 0. Momentum, भाई अगर body moving in xy plane तो it has velocity component along xy axis, not along z axis. It will be in xy plane, then z component 0. You understand or not? X, Y, Z, X, Y, Z. If XY plane is the floor, if body is moving in floor, then Z is 0. And there is a component along X, along axis. So PZ 0, Z 0. And hence Lx equal to 0, Ly, Z 0, PZ 0. 0. Only Lx left. Only Lx is Lz equal to xpy minus ypx. This is one question here, which is very simple for you. Dear student, there are troubles in learning always. When somebody tells me something to do freshly, then I don't understand in first sentence what the person is saying. The same thing may happen with me and you also here. So please, now you have recorded video. So you see again and again, keep on thinking, pause the video, think again, pause the video, think again, and you will get. But first start learning from the beginning, because if you don't know what is P equal to mv, then you can not understand. If you know what is acceleration, you can't understand. If you don't know what is angular acceleration, you can't understand. Now I have time here, so I'm taking here another question. A very good question which generally teachers do not do in the classroom. Here is a frictionless surface. Here is a rotating body like a disc, or it may be cylinder, but the cross section is spherical. But here it is given a disc rotating about its axis. Axis यहाँ से पास होगी सेंटर से, है भाई, rotating this way. एक क्या एरो दिखाया उन्होंने like this V. यहाँ point P, here is point A, here is point A, sorry, point A, and then point C here at distance r by 2. This distance r by 2. So here you are asked a disk rotating about its axis with angular velocity omega 0. Omega 0 is the angular velocity. It placed lightly, gently, without any translational push on a perfectly frictionless table as shown in figure. Disk rotating with angular velocity omega is gently placed on this frictionless surface. Frictionless. So what are the question here? This question of NCERT book. What are the linear velocities of point A, B, C? Number A part है, what are linear velocities of points A, B and C. So from relation V equal to R omega, VA equal to R into omega 0. VB in this direction. In the direction of the arrow marked in figure. Given a figure, K direction. VB again R omega 0, but opposite to this direction here. As directed in figure. Directed in figure. Dear student, omega angular velocity is also a vector quantity, you know. This is marked that this direction of omega is normal to plane of disk and into. If omega had been anticlockwise, then out. Well, I have told you, this is very important thing. And VC equal to R by 2 into omega 0. So this is first answer. Secondly, he is asking you, will the disk roll in the direction indicated? क्या ये डायरेक्शन जो है डिस्क ऐसे रोल करके आगे चलेगी? Will the center mass will move in the direction? The surface is frictionless. Actually, to rotate and move, center mass to move. To rotate here along the surface, we need a torque to rotate it further. But torque will be provided by here frictional force, which is not there. Frictional force is not there. So it will keep on slipping here on the surface. The disc will not, move in the direction of indicated, because to rotate along surface, torque is required. torque is required. And here torque will be produced only by frictional force. Here torque will be produced by frictional force. Torque can be produced by frictional force. Which is 0 here. Actually, when it will rotate, I will take another question here also. Then it will rotate only about point B if for a moment the point of contact of disc with surface at rest. It will try to slip forward and force will act backward. Only then it rotates, so it cannot move in the direction indicated. Then next part is there. Why friction is necessary for disc to rotate in the direction indicated? The same reason. Force of friction provides as a central force. Right? Then D part. If surface of the table is not frictionless, then what will be the direction of force of friction? If the surface is not frictionless, it has some friction, then he says what is the direction of frictional force at B and sense of frictional torque before perfect rolling. I have told you condition of perfect rolling in one video. Please read thoroughly. Don't select the video. I'm observing that the videos which have simple questions are viewed more than those videos which have some difficult part. Please, the difficult part is not there. But we don't study, we don't stress our brain. Stress yourself. So if there is frictional force, then the disc will actually rotating, it will slip here. The force of friction will be in forward direction. Or in this direction of torque. Torque, vector torque equal to, I told you, R cross F. R cross F. Direction are taking this way, R cross F. So outward, and opposite to the axis retardation पैदा होगा, that will be opposite to angular velocity omega. The sense of torque produced will be anti-clockwise up to oppose the rotational motion. Is that clear? And then before perfect rolling begins. Actually, why the perfect rolling begins? I told when VCM equal to R omega. So when the disc is placed with large angular velocity and surface frictionless, then when it rotates, here it is slip forward and that forward force will produce linear acceleration and which will increase the velocity V center of mass, and decrease angular velocity omega. I will explain. So perfect rolling will begin when point P comes to rest and velocity of V of disc at point B is 0. Then perfect rolling begins. Perfect rolling and the sense of frictional torque before perfect rolling begins. So torque will be outward R cross F. Means body it will produce angular acceleration in the direction which will produce retardation in angular velocity, and this force of friction accelerated forward produce acceleration which will increase linear velocity, decrease omega, and when this condition achieved, then perfect rolling will begin. Then what is the force of friction after perfect rolling begins? What is the So I have told during perfect rolling, force of friction is 0 because B is at rest. At point B, the velocity is at rest, so force of friction 0. During perfect rolling, you may note it. During perfect rolling, force of friction is 0. Thank you.